to make the first observations with the double pyramid OAH and the triangle alpha beta gamma, and the second with the double pyramid O prime A prime H prime and the triangle alpha prime beta prime gamma prime. And that experiment would seem to prove first that the Euclidean geometry is true, and then that it is false. Experiments therefore have a bearing, not on space, but on bodies. Supplement 8. To round the matter off, I ought to speak of a very delicate question, which will require considerable development, but I shall confine myself to summing up what I have written in the Revue de Métaphysique et de Morale and in the Moniste. When we say that space has 3 dimensions, what do we mean? We have seen the importance of these internal changes, which are revealed to us by muscular sensations. They may serve to characterize the different attitudes of our body. Let us take arbitrarily as our origin one of these attitudes, A. When we pass from this initial attitude to another attitude, B, we experience a series of muscular sensations, and this series, S, of muscular sensations will define B. Observe, however, that we shall often look upon 2 series S and S' as defining the same attitude B. Since the initial and final attitudes A and B remaining the same, the intermediary attitudes of the corresponding sensations may differ. How then can we recognize the equivalence of these 2 series? Because they may serve to compensate for the same external change, or more generally, because, when it is a question of compensation for an external change, one of the series may be replaced by the other. Among these series we have distinguished those which can alone compensate for an external change, and which we have called displacements. As we cannot distinguish 2 displacements which are very close together, the aggregate of these displacements presents the characteristics of a physical continuum. Experience teaches us that they are the characteristics of a physical continuum of 6 dimensions, but we do not know as of yet how many dimensions space itself possesses. So we must first of all answer another question. What is a point in space? Everyone thinks he knows, but that is an illusion. What we see when we try to represent to ourselves a point in space is a black spot on white paper, a spot of chalk on a blackboard, always an object. The question should therefore be understood as follows. What do I mean when I say the object B is at the point which a moment before was occupied by the object A? Again, what criterion will enable me to recognize it? I mean that although I have not moved, my muscular sense tells me this, my finger, which just now touched the object A, is now touching the object B. I might have used other criteria, for instance, another finger or the sense of sight, but the first criterion is sufficient. I know that if it answers in the affirmative, all other criteria will give the same answer. I know it from experiment. I cannot know it a priori. For the same reason I say that touch cannot be exercised at a distance. That is another way of enunciating the same experimental fact. If I say, on the contrary, that sight is exercised at a distance, it means that the criterion furnished by sight may give an affirmative answer, while the others reply in the negative. To sum up, for each attitude of my body, my finger determines a point, and it is that and that only which defines a point in space. To each attitude corresponds in this way a point, but it often happens that the same point corresponds to several different attitudes. In this case we say that our finger has not moved, but the rest of our body has. We distinguish, therefore, among changes of attitude those in which the finger does not move. How are we led to this? It is because we often remark that in these changes the object which is in touch with the finger remains in contact with it. Let us arrange then in the same class all the attitudes which are deduced one from the other by one of the changes that we have thus distinguished. To all these attitudes of the same class will correspond the same point in space. Then to each class will correspond a point, and to each point a class. Yet it may be said that what we get from this experiment is not the point, but the class of changes, or, better still, the corresponding class of muscular sensations. Thus, when we say that space has 3 dimensions, we merely mean that an aggregate of these classes appears to us with the characteristics of a physical continuum of 3 dimensions. Then if, instead of defining the points in space with the aid of the first finger, I use, for example, another finger, would the results be the same? That is by no means a priori evident. But, as we have seen, experiment has shown us that all our criteria are in agreement, and this enables us to answer in the affirmative. If we recur to what we have called displacements, the aggregate of which forms, as we have seen, a group, we shall be brought to distinguish those in which a finger does not move, and by what has preceded, those are the displacements which characterize a point in space, and their aggregate will form a subgroup of our group. To each subgroup of this kind, then, will correspond a point in space. We might be tempted to conclude that experiment has taught us the number of dimensions of space. But in reality our experiments have referred not to space, but to our body and its relations with neighboring objects. What is more, our experiments are exceedingly crude. In our mind the latent idea of a certain number of groups pre-existed. These are the groups with which Lié's theory is concerned. Which shall we choose to form a kind of standard by which to compare natural phenomena? And when this group is chosen, which of the subgroups shall we take to characterize a point in space? Experiment has guided us by showing us what choice adapts itself best to the properties of our body, but there its role ends. End of Chapter 5. Recording by Alex Jacoby, Ann Arbor, Michigan.